quart d'heure du sud-ouest.
Dans les bouchons, ce qui vient en voiture. On est bon?
Eh ben oui, oui, là, ça devrait être bon. Alors, ça devrait être bon.
Il faut essayer de quitter là.
Voilà, c'est bon.
Fermer ça là. Qui fait que découper. Hop. C'est pas ça, c'est ça.
C'est après ça. C'est l'autre. Voilà, c'est... Non mais là c'est une image maintenant.
Ouais.
Alors comment on fait pour la vidéo?
Ah ben il faut...
Du coup la vidéo,
hop,
voilà.
échappe,
Sur votre clé USB.
on va fermer. Et là,
Voilà.
est-ce qu'elle tourne bien sans ça connaît. Après échappe. Enfin, je peux rester à côté si
Ouais.
je reste sur le canapé au cas où.
Ouais, ça serait bien. Ouais. C'est bien, copilote.
Je croyais que les avions roulaient tout seuls moi maintenant.
Ah, presque, ouais.
Sur le lit, j'espère qu'il va.
Ouais, je pense qu'on est bon.
Le problème c'est que ça vole tout seul, sauf qu'il y a des centaines de personnes au sol à la rescousse, quoi.
Je vais même l'ouvrir comme ça.
Bon, donc j'ai plus besoin de tout ce truc. Là. Ça, j'ai plus besoin.
Je vais la mettre sur
Donc, tu
pause.
mets ton truc.
Il ne manque plus que Pierre Bénec.
Ah mais il vient en voiture donc il y a un bouchon.
Il est là ce matin.
Ah.
Je l'ai aperçu. Il m'a même salué.
Sinon, il faut faire, hein.
Sinon, on va
Faire ça.
faire lui. Hein. activer le partage. Bennec. Ouais, Pierre Bennec. Partager l'écran.
So, good morning, all of you, ladies, many ladies, gentlemen, dear colleagues. This is my great pleasure to open this conference. I should not have done that because it was normally the duty of the president of INPG, but unfortunately some other duties for him this morning, and we hope that Pierre Bennec will have the opportunity to join us this morning and to address some words on behalf of the host university of this conference. So first of all, I would like to thank again Université Grenoble-Alpes and INPG to welcome this conference in this beautiful amphitheatre, which is, I think it has been opened officially 1 week ago. So this event is the first event is in that beautiful room. And yes, so we are going to switch that, and if we have the chance to have Pierre Bennec during the next minutes, we will give him the microphone and the floor, obviously. So my name is Alain Bernard. I am the chair of that conference. I think it would be my last conference as chairman, as emeritus professor. And I would like to just to start with a question: why PLM 2022 is important for the community? So, first of all, the topic. The topic itself, you have to, if you had a look, and obviously you had a look to the topic because you submitted interesting papers, PLM in transition time. Well, we all are happy to meet again, and we know that the COVID is around, everywhere, still around, so you need to protect yourself and to be careful. But anyway, this pandemic had strong consequences on current lives. And for example, the topic of the next annual conference of the Academy of Technology in France will be sobriety. So this means that people are looking now for new practices, and obviously the direct consequence for PLM is that PLM has to be adapted to the new practices for the future. We speak in France about re-industrialization, for example. What does it mean in practice? We were discussing about competencies. What about the attractivity for industry? What does it mean? What is industry today? What should be industry? And what is the place of PLM and information systems in the new society, in the new industrial practices, and so on? So PLM 2021 has been totally in remote mode. We remember that. And we were all very much frustrated. And concerning myself, I lacked a chance to visit Brazil. Unfortunately, I never came to Brazil, but, well, I missed, but we missed, all of us. But the main consequence was for young researchers. And we see many young faces here in that room. This means that young researchers, they perhaps don't know each other before the conference. And attending a conference is starting a new set of relationships, but also constructing a network for future employment, maybe postdocs and employment, but also for life. Many of the older or oldest colleagues here in the room are part of my friends. Okay, why? Because a community first is to become friends and to like working all together. And when we know how to work all together, we work in the best way. Okay, so I think this is first consequence. And obviously, the subtitle, let's say, is The Place of Humans and Transformative Technologies. We speak about Industry 5.0, why not 6.0? But when speaking about 5.0, this means that human in the center of the system. We consider human as assisted and so on and so on. So I mean, we imagine a system which could be around humans and to be auto-adaptive with respect to the needs of humans. And information systems like PLM has a great role for that. I remember a project, a big project, regional project we had in Nantes with Stelia company as application field about what we called a ubiquitous assistant for humans and operators around the machines. Okay, how to identify the worker, his skills, and how to interact with him with respect to the PLM system, but also decision-making systems for assistance and adaptation of the context also of situation, working situation around the workers. So many issues have to be discussed, and humans are more and more conscious that natural resources are not infinite. And the same also, the main keyword, I already told you about that, is sobriety. So this means that we need to do maybe not more. We used to say that in the future, in the past. We said we need to do more with less. Maybe we will not do more, but for sure with less. And the main issue also is to see, for example, how PLM systems should be adapted for de- and remanufacturing, and also circularity, and so on and so on. So many issues that are part of the life cycle of the systems and the assets as a whole. What I call the just need, okay? Even for us, consumers, the just need. I just consume what I need, nothing superficial, okay, or in addition and so on and so on. Just what is needed. And the same for energy, water, materials, and so on. We need to have it in mind and to integrate that in our management systems. And obviously, PLM is the core source of information for the future. Oops. Okay. So this conference is very important for young researchers. Let me congratulate all the doctorate students who contributed actively to the doctoral workshop. We remember that our conference is one of the unique conferences that is open with the doctoral workshops that was organized yesterday. And thank you also for the seniors who coach the young researchers, the PhD students during that workshop. So we had 9 doctorate students, I think 8 because one late cancellation, but and also senior researchers from 5 different countries. So once again, extend also the variety of contributions by extending the number of countries for the next years. And let me end my talk this morning with IGPLM. I am still the editor-in-chief of the Journal of the Community, IGPLM. So who read in the past papers published in IGPLM? Please raise your hands. Okay. To be positive, I will say 50% of the attendance. Okay, this means that you may know about IGPLM. IGPLM is a journal published by Inder Science. And, well, we publish 4 issues per year. And we will have a special issue published during the next month about sustainability. So, obviously, 8 papers or 9 papers which concern sustainability. So we all have benefit to read that issues and also to contribute and submit good papers to that journal. Okay, so we don't need too many papers, but we need to share in that journal what we produce as the best results of our community. Okay, so IGPLM needs to progress also in the ranking, but it is always a matter of chicken and egg. Okay, if we have good papers, good citations, and so on, we will progress. But if we have a lack of papers and we have some, let's say, difficulties to push the journal, this will stay at the actual ranking, which is something which could be improved. And also selected papers of that conference are proposed to be published or submitted first, but published as extended version of your papers. Last year, we proposed that to PhD students, mostly. Unfortunately, I did not receive any extended version of any paper, okay? So this is a pity. Consider doing that, okay? Obviously, you have the opportunity to publish in other journals with our Q1, well-referenced, and so on and so on. But I imagine that for one of your papers, you can make that effort to submit it to the journal, okay? So have it in mind, and it will be the case also for this conference. We will select and propose to submit extended versions of papers to the journal, okay? And, well, the place to be for that conference, there are many places, but one of the places to be is Grenoble, obviously. If you have a look, to the weather, wonderful weather, you have a look to the area, but also to the scientific issues. You will have the opportunity to visit the new facilities and the g-scop laboratory with Professor Frédéric Noël, who is the key actor of the preparation of that conference. They are one of the best set of researchers in France and maybe in the world in the topics of PLM topics. Okay, so this is a chance for you to be there. So please enjoy your stay, enjoy the conference, and well, don't hesitate to discuss with anyone. Okay, we professors, we are very open-minded. Okay, and you may consider that this is a chance for you to attend the conference, for us to have you as young researchers. So we need to have this kind of discussions during the breaks and during the lunches and so on and so on. So take that chance 100%, okay, and enjoy the rest of the conference. Don't enjoy too much the weather and the area. We have wonderful keynotes and parallel sessions, so you need to attend the rooms, okay? So thank you so much, and let me give the floor to Professor Aziz Bourras, who is the chair of the working group 5.1, for which the conference is linked, okay? Thank you very much.
Thank you very much, Alain, for your kind words. And so dear colleagues, dear students, dear guests, and dear organizers and chairs, so good morning. I'm also very happy to be here and to finally reconnect with all the faces that I am used to see in the past. And I'm really proud and very happy that we are all together face in face. This is really wonderful. Probably in the future, we did not really see the value of this, but definitely today we are so happy to reconnect again. I will just say a few words from the IFIP point of view, and as you can see, I did not prepare for the first time. I did not prepare any slide, just for the sake to win some time. Time is running. So I will just say a few words from the IFIP point of view. So on behalf of the IFIP, which is the International Federation of Information Processing, and its working groups, technical committees, etc., I wish really to welcome you to this 19th event of the International PLM Conference. 19th. It means that we organized already 18, and I hope that we'll organize more than this. So when we started in 2003, I remember it was in Bangalore. In that time, it was organized by Professor Guru and Professor Deba from US. And it was only an international symposium. It was a kind of try. And then, just 1-2 years later, we were convinced. And the industry partners convinced us that we need seriously to sit every year, not every 2 years, and to make it a really international conference. And we started like this, and I'm really very happy and very proud. And IFIP also is very proud about the progress that we get around the PLM community. So we have I will not say everything, but as you can see, we have 18 books now, we have proceedings, we have a journal, we have a lot of people reading your articles, your contributions, your panels. So this is really a success story, and I wish really that this will continue. So we are one of the best conferences of the community in IFIP. IFIP is now more and more engaging the scientific community like us in producing evidence-based research and supporting decisions at the pace and scale where change needs to happen. And nowadays, it's becoming critical. So we have seen this with the COVID, we have seen this with the global challenges related to the environment, and beyond, we are seeing this also with the wars and more and more. So I think we have a real role to play somehow in this scale. So in such context is a call for our scientific community for a wake-up and a timely warning to all of us. The theme that my colleagues and all of you have selected this year, as Anna mentioned, PLM in transition times, the place of humans and transformative technologies, denotes really your willingness, our willingness to contribute to find the right solutions. It also shows how it became critical for universities and industries to join their efforts and tackle and take an active role in preparing the next workforce generation. Of course, this cannot be properly done or achieved without bringing together the businesses, the policymakers, the students, the research centers, and so on. To address the existing gaps and to create innovative and multidisciplinary solutions, adjusted to the current and upcoming challenges of the growing digital era. And we are very happy that we are tackling the PLM issues from the processes, from the project point of view, but also from the organization, the human and technologies. And we see how the new technologies are disruptive and how the new technologies are disruptive and creating solutions, but also creating problems to the community. More than that, this will help all of us to contribute to the sustainable university of the future. We have also to ask our questions the way we need to contribute to the society and the way the university need to play its role in the future. Things are changing and the university need to adapt itself to these challenges. To conclude, I'm just here to say that I'm honored today to see the Working Group 5.1 related to PLM and its activities successfully expanding its activities to new SIGs, because under the working group we have the conference, we have journal, we have doctoral workshop, and we have special interest groups. So the special interest groups are focus themes where colleagues and students and industry partners can just raise a problem and work on that from the knowledge point of view for 1 year, 2 years, 3 years, and then we close it and we go back to another SIG. So we are so proud today, and I was so happy to see that we have a new SIG called Next Generation AI to improve the performance of decision systems, proposed yesterday during the General Assembly. So I wish really that all of you can contribute to this SIG and contribute to the discussions, to the solutions, etc. I was also very happy as Anna to participate yesterday in the doctoral workshop and to witness the wonderful atmosphere between our young generation, the students, and the great dynamicity of our PhDs. So I really congratulate them about their work, and we are always waiting for them to be part of this wonderful group and to replace us in the future. I just wanted also to congratulate all of you for your wonderful work, either in organizing the conference. Thank you very much, Frederic and your team, and Grenoble ENP. This is really a fantastic opportunity for all of us to visit the city, but also to know a little bit more about what you are doing in the university, contributing to the conference, to the doctoral workshop, to the panels, to the industry visits, etc. So thank you all for all this, and I can assure you that the working group 5.1 and the IFIP will continue supporting our events and in particular the conference for the future. Thank you very much.
Okay, thank you very much, Alain and Aziz, for these kind words. I want, obviously, everybody to welcome you in Grenoble for the PLM Community Conference. That's something which is very important this year, because not because it is in Grenoble, but because it is the first time after the pandemic when we can join all together and meet once again. So that's very great to be here, and the first thanks will be to all the community to be here today, because you made the effort to take planes and to travel to Grenoble. So thank you very much to all of you. Oh, we have some elements that we should mask. Just some key figures about the PLM conference as it is today. And I welcome my president who will come in a few minutes. First, the doctoral workshop, it was said, about 9 students and 8 senior researchers who participated yesterday. We received 94 papers which were submitted. We selected 67 papers with a success rate of 75%. We will have 5 keynote lectures, and we will have also 5 industrial talks which have been invited to the conference. So that's something which is quite important. We have registered about 109 persons to the conference. Most of them will be here today and the next days. We only have 4 persons who expected to come to connect by video conference. Unfortunately, maybe we will listen about some travel issues or some COVID issues in the next day. So maybe we will not be all here, but I guess already more than 80 registrations this morning at the desk, so that's something which is very good. We are about 18 countries, and you see the repartitions. Obviously, France is well represented today, but there is also Germany and many other countries who are here. You have a list of the countries on the slide. Okay, why product lifecycle management in Grenoble? Alain told some words about that, but I will say that we started with an integrated design research team in 1991, so it was about 30 years ago already. It was led by the Professor Serge Tischkevich, and we go ahead in these directions with a first thesis about socio-technical approaches in 1993, something which was very seldom in research. So the place of humans' respect to technology was already on board by this time. We go ahead with multidisciplinarity between technology and social and human sciences in research, but also in industrial engineering. We have here an industrial engineering school, which hosts us, which is typically dedicated to this connection. It was thus really natural to us, the PLM conference, with a place of humans in transition times, technologies, in all the transition times that you know, and I will not repeat what was said by Alain about these issues. Okay, I will try to make an overview of the program. The program is already organized with keynote sessions every midday with scientific parallel sessions. So that's quite organized every day like this. We will end this afternoon with 2 parallel roundtables in this auditorium and in a closed auditorium, one about MBSE techniques and one about the place of humans respect to the organizations and to the technologies. We will finish the day with a welcome cocktail and a visit to the Grenoble Art Museum. We'll go by walking from here to the Art Museum. Tomorrow, we will start again, and you will be able to, there is a paperboard in the welcome zone where you will be able to register to groups in order to have towers and to visit the technological platforms starting at 8:15. So you can make the groups today by putting your name on the dashboards. Then we will have a new keynote, parallel sessions again, and the afternoon will be dedicated to industrial presentations. So we'll have a keynote from industry once again, and a full industrial sessions with presentations of invited speakers and a final panel discussion. And traditionally, we'll end the day with a gala dinner, which will be hosted at 16 kilometers from there in Visil. And we will go by bus. The bus will start from the institute here. The last day, we'll have once again a keynote lectures, parallel sessions, and the closure sessions. And in the afternoon, you will have opportunity for the people who are registered to visit ESRF and to visit the Caterpillar plant and their production system. Okay, everything is organized here in this room, mainly in this room, but we have also 5 parallel sessions in some sessions. Everything will be in this building on the first floor, just beside here, or maybe for the next session after the keynote, on the second floor, there is one room which is reserved for that, but everything is well located in this building. The pause are at the welcome reception, and the lunches will be in the cafeteria of the School of Industrial Engineering. So it is just there. I'm sure that you will find very easily. Just to let you know, to get better organizations, you have this booklet which was put in your bag when you arrived. There is a tag here with an address. If you go and if you follow this address, you will find a website where you will find the booklet again. If you lose it, maybe you will have the connections which will remain. All the conference papers, the 67 papers, and Visio connections for whom is interested to connect to the Visio conference. Because we have Visio conference, we need to try to make the connections with the few persons who are in remote locations. So it will be better to locate your presentations on the local computers rather than on yours. So if you can arrive with your USB key, it is possible to use your computer, but then you will need to connect to the Zoom connections also in order to share your presentation with remote users. We will have helpers. They have blue t-shirts. You already meet some of them. I would like also to thank everybody, Romain, Guillaume, Abdou, Gilles, and so on. I will surely forget some names for the organization of the conference. I was not alone, obviously, in this case. The blue shirts, the blue t-shirts, yes. The blue t-shirts are the helpers in every room. The chairman will be the timekeeper, and I see that we are always very late. The pauses, I already said that, will be in the welcome area, the lunch in the student cafe. And obviously, you will need to register for the tower tomorrow morning, just to make groups in order to organize the visits quickly. Okay. Not to be longer, enjoy the conference, enjoy your stay in Grenoble, and thanks a lot for your commitment. And I will pass the floor to my president, Professor Benek, in order to introduce He was supposed to be here at the beginning, but I'm assuming he has an important meeting before. So thanks, Pierre.
Well, it's a great pleasure to welcome you in Grenoble in this new amphitheater, and I just want to tell you that for us it's very important to have such a conference on this subject, which is very important, and I am very proud to have all of you here in our site, and I expect that you will enjoy your stay first, and you will exchange. It's the more important things, to exchange all together, and to construct some new project, because it's on such a meeting that new idea can begin. So it's very important, and I expect that it will be fruitful for all of you. So welcome. Excuse my short apparition, because I have a lot of things, but I will think to you, and I will tell with our colleague to know after this meeting what it happened in fact, and what can be made to go further on those so important subject. Thank you. Goodbye.
Okay, so just to go ahead, I guess that the welcome session is closed, and we will open the next sessions, which will be chaired by Romain. Thanks, Romain.
Okay, so good morning, everyone. I'm very pleased to introduce Guy-André Boy. So Guy-André Boy is our first keynote speaker. He is currently Professor of Human Systems Integration and Human-Centered Design at Centrale Supélec and Estia Institute of Technology, which are both our engineering school in France. Guy has a very, very rich CV. I will not go to the beginning of his career because I was not even born, I think. What I can say about Guy was in 1992 co-founder, president and chief scientist of the European Institute of Cognition Science and Engineering, which was a joint research laboratory between the Airbus company and the Thales company. He was a member of the scientific committee of the Single European Sky for Air Traffic Management Research Program. Then he became chief scientist for human-centered design at the research center of the NASA, the Kennedy Space Center, between 2010 and 2016. He was then university professor and dean at the School of Human-Centered Design at Florida Institute of Technology up to 2017. And more recently, Guy was elected fellow of the INCOSI, the Air and Space Academy, and the International Academy of Astronautics. He is a senior member of the Association for Computing Machinery, and he is also leading one very interesting working group of the International Council on System Engineering that concentrate on human systems integration. And the latest news is maybe the FlexTech chair. So Guy is leading a very attractive research project in France with a lot of international companies, such as the National Air Force of France, but also Airbus, Thales, and many other companies on the design of flexible technology. And I'm pleased to welcome him to tell us more about what is a tangible technology, and the title of his keynote is Life Cycle Digital Engineering, the Tangibility Issue. So please welcome Mr. Guy-André Boy.
Good morning. So first, thank you to the organizers of this conference to invite me. So this morning I'll talk about tangibility. Tangibility has become a very important concept today because our world is more and more digital and virtual. And then what is tangibility, in fact? So physical tangibility is about grabbing objects, sensing, you know. When you grab a pencil, you know, you hold it. But there is another meaning that is more cognitive. This is about grabbing concepts or abstractions. You know, sometimes you say, what you're saying is not tangible, means I cannot grasp the concept, you know, that's the thing. And then today, with this digital technology, these two concepts needs to be better articulated. Sometimes you don't need to have a physical tangibility, but you absolutely need figurative and cognitive tangibility. So, so this is the the outline of my talk. First, I'd like to show you that we inverted the hardware-software dependency from the 20th century to the 21st century. Second, we are starting to consider unexpected events. There are even conferences and workshops on unexpected events. And sometimes, you know, like COVID, for instance, you know, it's unexpected. Well, it was quite possible to expect, but probably our approaches were not there to warn us. Third, we start to understand flexibility and autonomy better. So autonomy is very fashionable today, but we'll try to better understand what we mean by autonomy and flexibility. Fourth, we are no longer in a single agent-based engineering era. We have moved really radically to multi-agent. Fifth, we are complexifying our socio-technical world. Socio-technical systems were already introduced in this conference before. I like to show how complexity grows today. Six, we are making human systems integration a discipline. I mean, this is more than a wish today because I'm running this human system integration working group in COSI. And during the last workshop, we had 350 people. So it's not nothing. And 24 countries. So I will develop these 6 points. So first, tangibility issues. They emerge from virtual human-centered design. This was my car when I was a student. I was a student at Super-Héros in Toulouse. And I could repair, you know, the car. I mean, I can tell you that this Citroën deux chevaux, as we say in French, I think this was the only car that could be dismantled with a 12 millimeter inch, you know, key. And you had to know to put it back. But so that was quite tangible. Very, very few electricity, only for the lights and the shock, you know. And then today, we moved to that. You know, there was you know, I had a problem with my steering, power steering, and so I went to the garage, and the guy came with this tablet, and he put the USB under the steering wheel, and he said to me how much it costs to repair it immediately. And he went back to the office, and I said, well, you don't tell me what it is. And, and he said, oh, you want to know it? Yes, I want to know. And he came back, he put it back, and he read the second line. So this is where we are today. So we moved from hardware to software during the last 3 decades of the 20th century, mostly. So automation and human-computer interaction emerged to become very strong. And from a human factors point of view, there was really an issue. Today, 21st century, we start from software. We actually start from a PowerPoint slide deck. And then we design a model, software model, and then a simulation, and then a simulator. You know, the first really concrete design of this was the Dassault Falcon 7X, Sphenex, 2005, you know, where the test pilot flew the aircraft, the virtual aircraft, and the aircraft was not even developed yet. But the beauty in this is that they developed everything, including the cockpit. Usually the cockpit is done in the end, was done in the end, but there they could test, you know, the activity of pilots in a virtual world. Which, oh, sorry, I put this photograph because this was my lab at FIT when I was, you know, we had in the same lab, we had 2 simulators back to back. You know, one was an A320 Airbus, and the other one was a 737 Boeing. I think there was one of the only lab in the world where you had Boeing and Airbus in the same room. So we were designing things. You know, at design time we could test it with the pilots, and then back to the Falcon 7X and the followers. This is one of the best business jets in the world. So, but tangibility became the problem. You know, we can do human factors very early during the life cycle of a product. But we have to make sure that this is real world. This is real. It's virtual world. So in fact, we have to develop measures of tangibility. So this is what my talk is going to be about. And then also, this kind of approach improves flexibility as well. So during the 20th century, to summarize, I took this example of a nuclear power plant. We designed, you know, this power plant. This was engineering based. And then we figured out that there were going to be people operating this facility. And then what we did is we put an interface in between. So in fact, we had to implement the interactions between the humans and the machines and the facilities. Huge control rooms, as a matter of fact, here. So what we did is we designed the facility first, and then we took care of the human factors after, okay? Sometime a bit late. So I call this approach inside out, inside the technology and out to the people. And then disciplines developed, engineering, of course, ergonomics, human-computer interaction, and automation. But the problem was we went from means to purpose. First, we designed the technology, the means, and then we figure out how to use it, if you want. And then what is the purpose of doing this, and we learned along the way. Now, 21st century. As I said before, we start from software. And then we can develop a virtual plant, if you want, okay? Because we know the models of, you know, the nuclear reactions and things, and so we can develop a very, very fine models and simulators. We call this approach outside in. So in fact, we can put the people in the simulation very, very early. Then we have to tangibilize this. And then we have to incrementally develop the system by step, you know, and then come out to the real thing. I call this approach HSI, Human Systems Integration. So this is the opposite of the other approach. We go from purpose to means. We start by trying to better understand the activity and then develop the means accordingly. So we need tangibility measurements there. So I'm developed with the team at NASA. That was quite a while ago, 10 years ago. This approach, trying to develop these tangibility attributes. We put 5: complexity, maturity, flexibility, stability, resilience, and sustainability. All this you know, but we try to put that together. We try to integrate, you know, this kind of thing. So complexity, you know, we try to better understand what the separability issue is about. You know, in medicine and physiology, the people understand separability for a long time. In a complex system like the human body, for instance, there are organs that are separable. The hand, for instance, you need to know how to put it back. But the brain is not separable. I mean, if you separate the brain, and the individual dies. So this is the same for complex systems in general. Interconnectivity, collaboration, trust, all these kind of things emerge from the study of these complex systems that are highly interconnected. Maturity, you know, for quite a while now, probably 30 years, we have developed these TRL, technology readiness levels. Everybody knows about that, right? This scale, 9-step scale, you know, was fairly developed by NASA, by the way, and then developed all over the world. But we realized that there are other readiness levels that we need to consider. HRL, human readiness level. Are the practice adapting to the development of the technology? Is there a scale for human readiness levels? So the US Air Force developed HRLs for quite a while now, and we are continuing to do that. And we have introduced another one that is ORL, organizational readiness levels, because you know, you have to include this technology in the society where it will actually evolve, you know. I will be back on this later on. Flexibility. So there are several other sub-metrics, if you like, that are developed, like safety notes, reversibility. My chair at Central Supélec and SCI is called FlexTech. Why? Because we try to develop technology to increase flexibility, and I will explain why in a few minutes. But FlexTech is very important in the case of unexpected events, where the procedures, the automation doesn't work anymore. Stability and resilience. How can we come back to the normal situation? And sustainability, that is about, you know, after, you know, I've been involved with Aerospatiale at that time, in Airbus, in trying to find out some design rationale of the Concorde at the end of the 90s. We started to see some issues that ended up, unfortunately, by an accident. But before the accident, we were really interested in trying to find out how to maintain this aircraft that was designed in the 60s. And the way the people designed in the 60s was totally different from the way we are designing today, as I show you. So in fact, okay. And then there are social factors that emerged in these tangibility issues. Shared situation awareness, cooperative decision making, harmonized risk-taking. Risk-taking is really an issue today, because what do you do when you took all possible precautions? And I know what I'm saying there, because in space, in the space programs, I worked at NASA for many years, we try everything to prepare a mission. And then at the last minute, you have an unexpected event. What do you do? Do you wait? Do you do something? What do you do? So that's about risk-taking. Trust and collaboration with very complex systems that are more and more, I don't like the term AI, but they are more AI-based, if you want, very highly automated. So second point is about handling unexpected situation. You know, in safety critical systems or life critical systems, I worked on this for probably 45 years now, we develop procedures. And we develop, and these procedures automate people. So in fact, you have to apply the checklist. You know, you have to do the checklist, the do list, and you have to do that. If you don't do it, then you could be sued, you know, if you're a pilot. And then you automate human functions doing this. Automation, what we call automation, is actually putting procedures into a computer. Then you automate machines. You automate system functions. All this works perfectly, and I can tell you that the deaths after accidents, aircraft accidents, decreased exponentially, reaching zero. In 2017, there was actually zero deadly accident. Unfortunately, after that, it went up a little bit with the 737 MAX. But the problem is everything works very well in very well-defined context. But this is very rigid. When you push the button or the automation, the system does what is as in this billy. You know, this is the way it works. And this is the same for procedures. Once you apply the procedure, you follow the steps. What happens when we need to deal with an unexpected situation? Well, you have to solve a problem. And from a cognitive standpoint, solving a problem is totally different from following a procedure. You need to be, you need to have a competence for doing this. In aviation, we talk about airmanship. You know, you need to know how to fly, and you need to know about the systems that are on board. And people are really the resources for that at the moment. And then you need sometimes, you need to collaborate with other people, with the ground, the people in the air traffic control, for instance, or with the system engineers on the ground. Then you need to coordinate autonomous agents. We say that this is another space that needs to be flexible. You need flexibility in this case. So rigid, flexible. All this could be grouped under the function allocation arena. But the function allocation should be addressed to humans and machines at the same time. And sometimes we forget the flexible part. We develop only the white part, the rigid part, without saying that it's rigid, in fact. And this is the challenge that we have today because of the complexity of the interconnected, super interconnected systems. So my slogan is how to go from rigid automation to flexible autonomy. This is the reason why we developed this FlexTech chair. Let me give you an example. The example with technology, you know, a tangible technology. The undo function, you know, when you type a text, you make an error. If you don't have the undo, you're going to be stuck. You know, it's going to be pretty rigid. Undo provides flexibility. So I define this as a FlexTech. See? But FlexTech is not only related to technology. It could be related to the organization. I don't know how many people saw this movie, the Apollo 13 movie. You know, there was more than a movie, there was a real thing. You know, where the astronauts in the capsule, an explosion, and they had this CO2 remover failed, and then the guy on the ground, you know, the flight director, you know, asked the engineers to make a new one, a new CO2 removal from the objects that were in the capsule and in the LAM, the module. And they made the thing, and then they made the procedure, and they sent the procedure, you know, the building procedure to the astronaut. That finally succeeded and came back safe to Earth. This is about collaborative problem solving. Another example, this is about the competence of people. You know, I've been involved in the design of the development of this lunar rover, the piloted rover. Very interesting experience. It was started in 2006. And we started by, you know, very highly creative sessions where 35 people and working on the, you know, the design of this new rover. We had one guy, actually, Jack Schmidt, who drove the rover in 1972 on the moon, the initial one. It was a kind of very great experience that we had with this guy. But in fact, we had to design this pressurized rover, and then we tested, you know, we incrementally made we had two artists with us. We made cartoons, you know, to explore the moon with the rover. And then we made a movie, an animation. And then we made first prototypes, software prototypes that we simulated like a cartoon movie, if you want. And then we started to build the real stuff. We tangibilized, as I said before. And then we tested it this is in the Arizona desert. I have the movie, but it didn't work with, you know, there's still this antagonism between Macintosh and PC. So in fact, I cannot show you on the slide. We have to make a manipulation. So this is back to the manual control.
It's flexibility.
So this is this rover. We designed it to be very operative in the sense that you could do this. You can do that. You know, it could be very useful to park cars, but on the moon it doesn't matter. It's and so. Pressurized, and one of the issues that was very important was, you know, how do you get out from the rover that is pressurized on the moon, you know, and so this is the way we did it. You know, usually it takes 45 minutes to wear this space suit in the space shuttle or in the space station. Here it took 2 minutes. So, well, we didn't test on the moon yet. So you see the progressive tangibility. We start from a movie. We start from PowerPoint, in fact, and the movies, and then very important. We worked with artists. That was really great to share among the 35 people working on this, to share the same ideas. You know, because if you don't understand something on the movie, then you say, well, I don't agree with this, and then the guy modifies the movie, and this is the same thing at each step of the tangibilization of the. So in fact, all this is scenario-based design. I'm using all the buzzwords here, but you know, the difficulty is actually to invent the scenarios where you can test the thing, because if you design this amount of time, the test is this amount of time. You know, this is so that's the kind of thing. So I can go back to the slide. I'm sorry to put you on the spot. Okay, so flexibility is about technology, you know, the undo function as an example. About organization, remember the Apollo 13, you know, that was pretty well organized. I mean, they really thought about the possibility of these kind of failures, but not specifically this one, but and the people, you know, the competence, and most of the time you have an antagonism between creativity and experience. Experience is extremely conservative, but this is extremely necessary. You know, I remember, you know, the old guys, whether at Airbus or NASA, these are my two experiences in my career, really deep. You had also people, you know, the old guys, you know, say, you cannot do that, you know, that's, and the other guys say, no, this was your time, you can do differently. And so you have to put that together. You know, this is very important. You cannot neglect one of them. This is important. And that's where the difficulty is and where the beauty is also. I mean, this is important. So this triptych, you know, technology, organization, and people, this is what I'm teaching to my students. I call TOP, you know, top model. You remember top model, of course. And so this is why I call it this way. So third point, flexibility. This is a book I published last year, as a matter of fact, for the chair. So let me show you something. You know, this is the way we used to design things, and engineering design I'm talking about. You know, usually if you take the red curve, you know, on the axis you have the life cycle, you know, with the phases, you know, the design, the manufacturing, the certification, operations, support, and dismantling, that sometimes we forget. And then on the coordinate, I have three curves. Doesn't matter the unity of that. You know, if you take the red curve, most of the time you have to commit with the old approach, technology first and people after. You have to commit very early on the resources. So whether it's because you have a manufacturer working with suppliers that have the technology, and then, so in fact, you come up with a curve like this where you don't have enough steam in the end. You know, this is you have invested most of the money. The design flexibility follows the exactly opposite curve. In fact, the more you commit with the resources, the less the flexibility you have. And then the system knowledge, what you know about the system that you are developing, you know, is increasing when you use it. When you start to put things together, you integrate and you use and you operate, you know, this kind of thing. So now, if we take, this is technology-centered. If you take a human-centered design approach where you do this modeling and simulation I'm talking about, you know, virtual worlds and things, then you have this window that I call modeling and simulations, where, you know, you have lots of flexibility, of course, because you can modify the things anytime you want. Sometimes too many times. You have to stabilize. And then the system knowledge is increasing in the beginning as well. You know, you don't need to wait too long. Of course, with the tangibility issue, of course. This is why I raised this issue. And then the resource commitment is as a matter of fact, the concavity of the two curves, you know, flexibility and resource commitment inverted. So we are doing this kind of approach with well, I don't know if yeah, okay, Safran. At the moment, on the maintenance of helicopter engines, you know, Safran is developing, is making engines, first company in the world for that, and they're maintaining 80% of their park. So they have issues every day, and they have to figure out what is going on remotely. So in fact, the approach that we are developing is a digital twin of engines, you know, in order to play the what-if kind of things, in order to better understand what is going on, you know, in Africa or in the north of Canada, where the people are stuck in the snow or in the sand, or you know, things like this. So in fact, back to this curve, you know, where we do modeling and simulation. If you expand the modeling and simulation as a virtual world, you know, in parallel with the real world, then you have what you can call this digital twin of the real world, you know, the engines in this case, you know, so you start from the beginning by designing the engines, and then you continue by using the same kind of model that you can upgrade, of course, because now we have, again, I mean, machine learning is kind of buzzword, but you can learn, you know, for experience, you know, you add things and things like this. So in fact, you expand this human-in-the-loop simulation during the whole life cycle, and you can play what if. This is also could be considered as a vivid documentation. You know, I've been working on this at NASA for many years. A long time ago, that was the late 80s, beginning of the 90s, in fact, for the space station. And then you can maintain this virtual world in parallel with the real world in order to use it when it's necessary. It's kind of recommendation, procedure-based kind of things. And we can call that organizational memory. So today we talk about digital twins. And you can consider these digital twins as virtual assistants. You can say, okay, what could be done if we do this? You know. Okay, so I have two PhD students on these kind of issues, one with Total Energy and the other one with Safran. So now we raise, I hope that I'm not too late. So it's the half of the race here. So let's develop the last 3 points. Tangibility requires an appropriate systemic ontology. So in fact, we realize that we need to develop better knowledge representations. And as a matter of fact, going from single agent systems to multi-agent system. So I give you a flavor of that. So first, what is a system? Usually when we say the word system, people have in mind a machine, right? But when you hear physicians, medical doctors, and they talk about the cardiovascular system, it's not a machine, it's an organ, a biological organ. They talk about the cognitive system. You know, it's a real thing. So in fact, a system is a representation. This is the way we take it. So in fact, the idea is, for a long time, we thought about systems, you know, this is what I learned when I was a student, a while ago. A system is characterized by an input and an output, and in between a process. Now, let's start to develop this very simple ontology. A system, as I said, could be a human or a machine, a natural entity or an artificial entity, if you want. And then, for instance, you can say that the system can include another system. You know, for instance, I don't wish to use that, but a pacemaker is an artificial system that could be included in a natural system, you know, and make it work. You know, that's same thing for a car. When you are in a car, you are in a mechanical system. So either inside or outside, I mean, you integrate this along the way, and you need a way to represent this integration. This is why we developed this approach. And then the second thing is a system is mostly characterized by a function and a structure. You know, the heart, for instance, the heart has a structure, and the function is to pump the blood. But and the same thing for the carburetor of the car, you know, and things. And the function has to be in symbiosis with the structure. That's very important. I used to learn, not to learn, but to study a long, long time ago the human respiratory function. It's beautiful. The lung is beautiful. You know, it's very adapted to the phenomena of convection and diffusion. This is really interesting, which are functions. So in fact, and the function could be either physical, you know, like pumping the blood for the heart, or cognitive, you know, thinking, you know, the heart doesn't work by itself. It has signals from the brain, you know, and in order to beat. So, and the same thing for the structure. So in fact, we have this representation that we make us transform the initial representation of the system that is a single agent on the top here to a system of systems. In fact, a system is always included in a bigger system. And a system includes other systems. You know, this is a recursive definition of a system. I have no time to enter into more details, but this is the trend. So in fact, you have structures of structures and functions of functions that you have to superimpose. And sometimes it doesn't work very well because you don't know if this one works very well or not, you know, and this kind of thing. But when you put this system of system in activity, then you start to see this yellow function that we call emergent functions that you didn't anticipate in the first place. Then you have to put the system in activity to realize that, well, you have a straight line, but in some cases you have to do this. You know, this is and so the thing is, this is why modeling and simulation that are really possible today enables to implement human-centered design. In other words, to do human-in-the-loop simulation very early, and that enables you to make emerge these functions that you cannot see at design time on paper, if you want. And at the same time, you may realize that you forget to develop a part of the system structure. So all this is actually developed incrementally, and it's developed by considering metrics that are shared situation awareness. These are examples, of course. There are many more, but speed and precision, resilience, trust and collaboration. So all this enables you to figure out these emergent functions and structures. This is what we are currently doing in the FCAS design, the Future Combat Air System, that is currently developed by Dassault and Airbus, where we have started to simulate that as virtual stuff, you know, and then incrementally we test that more tangibly. Fifth point, complexity. So as I said before, a complex system, you know, there is a difference between complex and complicated. complex, well, complicated first. Complicated sometimes is bad design. You know, we add things and we don't realize that is actually a mess. And then you have to simplify. But complexity, the opposite of complexity is not necessarily simplicity. It could be familiarity. When you get familiar with a complex system, you know, for instance, if you change, you know, from a place to another, you know, you relocate to another place, you live in another place, then in the beginning, you find everything complex. Why? Because it's hard for you to connect the pieces of the landscape, you know, the bakery and the supermarket and I don't know, the car garage and all this. There are nodes, and then between the nodes you have connections that are related to the work you're doing, the activity you have. And then after a while, I mean, you get more familiar with that and you find everything very simple. But in fact, what you have done is you got familiar with the system. And so this is very important to understand because, you know, getting familiar with the system means that you can isolate some parts that are independent from the other parts that are dependent. You know, so this is what we call separability. In fact, this is, okay, I have no time to further develop. What is going on? Second point for complexity is the way the people interact among each other, or the systems, if you want. System, human and machines, and human and system of systems, if you want, including human and machines. The first one is supervision. This is the way we have done for years, centuries. You know, you have a boss and then you have workers, or you have a system with subsystems, you know, and things like this. This is supervision. The second is mediation. You have a middle ground where, you know, the one part, you know, let's imagine two countries, for instance, and they try to interact among each other. And then you have diplomats in the center that enables the interaction between the two. You know, it's like, for instance, you know, when you have a desktop on your computer, this is a mediation system that enables you to interact with the computer, you know, and back. In the beginning of computer science or computer engineering, we were pretty much at the supervision. I remember when I started in the 70s, we had to go to the system engineer, say, I don't know what to type here. Is it \**day? And then you were supervised by people to interact, you know, among each other. And then the other one is cooperation. Cooperation is currently what the people do. You know, when you start to interact with other people, with another person, you start to build a mental model of the environment, the other people, the organization, in order to better interact with the system. You know, we have these very, very small things on Google, for instance, learns from you, you know, and offers you some publicities adapted to your browsing experience, if you want. That may not be good or bad, I don't want to judge. But that's the kind of thing. So in fact, when you design complex systems, all this is very important to consider to better understand the complexity of the problem. I didn't click on the right thing. What did I do bad? Okay. If I want to go back? Okay. So I put two axes here. You become more autonomous when you go from supervision to mediation to cooperation, and you need more knowledge to do that. Okay, so when I talked about human-in-the-loop simulation. I talked about also scenario-based design. This is, I go fast on this. This is a methodology that we are developing called PRODEC, in fact. And it's not yet published, so I'm sorry, I cannot develop better the concept, but what I can say at this moment is that we used to do more DEC Pro than PRODEC. In fact, Pro is for procedural, and DEC for declarative. In fact, the idea is when this is coming from cognitive psychology, but the computer scientists took that for procedural languages in computer science and for declarative languages. In fact, when you design a system, this is important to start with stories and go to the design of means, from purpose to means, if you want, and not from means to purpose. So that's the kind of thing that we are developing right now. So we are doing this with Total Energy in the design of a fleet of robots. I mean, they want to replace the people, the human operators on drilling platforms on the ocean, which is an activity that is extremely dangerous. And in fact, in order to avoid this, dramatic accidents, they are developing robots. So in fact, we took exactly the same approach as I said before, starting with modeling and simulation, and then tangibilization. In the southwest of France, there is a base in a city called Lac. There was the old Elf-Aquitaine drilling facility. Then they equipped 3.5 hectares of a big lab, with physical stuff, tanks and tubes and things, and then we have these robots going there, and so that's a thing. So my last point is about this HSI, Human System Integration. This was my 2020 book that described the thing. So in fact, we want to go from this traditional engineering where we develop, technology-centered stuff, as I described, that led to automation and procedure following. You remember that. And then introduce some structural and functional rigidity in design and operations. And whether we admit or not, I mean, people had to adapt to the system, even if human factors and ergonomics people are saying the opposite by designing user interfaces, but you have to adapt, to the system. In Industry 4.0, and I would say, last month we had a meeting at Incosi, and for the first time came out not Industry 5.0, but Society 5.0. I like that. And but what I want to describe here is this digital engineering capabilities that we have today that promote human systems integration. What did it do? Okay. So human system integration has a combination of human-centered design and systems engineering. And that leads to autonomy in a sense that we have to work on problem stating and problem solving from the beginning of the design, and offering this flex tech stuff to the people. In addition to the procedures, of course, and automation, but that's not spoken. So the disciplines behind this are human factors, modeling, and human-in-the-loop simulation. More than that, but I want to highlight this. Data science and artificial intelligence could be useful, but as a support, not necessarily as the ultimate solution. Then we end up with structural and functional flexibility in both design and operations, but we need to emphasize other things that were probably less emphasized before. Creativity, complexity analysis. This is important to go in the classes to go beyond linear algebra, if you want. Complexity stuff is very important to understand. Agility, tangibility, and maturity, as I described before. And then systems that include machines and people co-adapt. This is really the key issue to better understand. And this is what HSI is about. So we have this incremental adaptation of TOP, top model, technology, organization, people, towards maturity and towards these new readiness levels. So I give you a flavor. You know, the initial TRLs that are presented this way most of the time have to be associated with human readiness levels and organizational readiness levels. All this is documented now. Of course, this is incrementally defined, but I can give you the references if you ask. Concluding, I think it's important to be aware of various possible contexts. Context is a key thing, you know. So in order to discover context of use of systems, like we did for the lunar rover, for what is being done for the design of new aircraft, for instance, or things like this, you have to develop scenarios. And scenarios have to be defined from past experience, but also from creativity. So in fact, this is the combination of creativity and experience. And then develop human-in-the-loop simulation and iterate. You never have the good solution in the beginning, of course. And elicit these emergent cognitive functions. This is elicitation of emergent things, properties. So scenario-based design requires solid conceptual models. This is why we have developed this ontology of systems that I introduced. One of the models that we use the metaphor of the orchestra, in fact. This is interesting. When you have a big organization, you know, I've been involved in the design of the A380. It's huge stuff. You have many organizations. And the people don't talk exactly the same language. You know, it's like if you want to play a symphony, if the people who design the symphony and the people who play and the people who design the instruments do not have the same music theory, that would be a mess. So we need to develop this music theory as a common framework for interaction. We also need to develop this composer function. You know, in an orchestra, the musicians have scores facing them. And the scores are coordinated by the composer. You know, if the percussionist starts at the wrong moment, it's gonna be quack. You know, and then you have conductors. You know, at the performance time, then you have to give the tempo, and you may not play the same with a conductor than with another, as with another. Musicians, this is about competence, engagement, and cooperation. You listen, you know, you have antennas everywhere. Audience, these are the end users. We may not play the same symphony in Grenoble in the Scala of Milan, probably. So I want to finish. It's not yet finished. I have 2 minutes. This is the schema that we have designed during the last 2 years at INCOSI HSI Working Group. So we started from this technology, organization, and people triptych to define HSI within an environment that we have to also to better understand and define. And this within several perspectives that I put. I will not comment too much this, but so we developed that in many perspectives. The systems engineering handbook of INCOSI is being made right now. It's going to be published in 2023, and this will be part of it. And in addition to that, we are developing a primer about 100 pages of HSI that describes all these parts. And then, more importantly for academics, what are the funding disciplines that enable us to better implement HSI? So systems engineering, of course, but socio-technical systems, system of systems, agile development, design and system thinking, model-based system engineering, all this, I saw the program is going to be developed during this conference. But also human facts and ergonomics, this is about task and activity, this is about organization, this is about performance, this is about evaluation metrics. Information technology, this is about human-computer interaction, artificial intelligence, visualization techniques. Is it going to be 3D, 2D, and how do you visualize things? Modeling and simulation. And then, like the three musketeers, there is a fourth one, which is the operational domain. If you work in medicine, it's not the same as aerospace. Then you need operational expertise and experience that is included there. And this is very useful for scenario elicitation and experimental test personnel. You need to have these people collaborating. So, a few takeaways. First, we live in a digital world, I think you agree. So tangibility has become a very critical contemporary issue. Second, we are moving from single agent ergonomics to social ergonomics. I published a paper recently, if you're interested, on social ergonomics. Human-machine teaming, this is becoming very popular right now. And why? Because the machine is not considered as a tool only, but it could be considered as a partner. And then what are the new human roles in this? How do you deal with a partner? Do we need to do that also? In some cases, maybe not. We know we go from rigid automation to flexible autonomy. I commented that. How do we deal with the unexpected? Well, we need to find this problem-solving support, the undo. We used to go from means to purpose. People adapt to the machine. And then I think the goal today is to go from purpose to means, to better understand the adaptation in both ways. Collaborative work that is at stake here requires openness, education, empathy, and enthusiasm. I hope I've been enough enthusiastic here. And thank you very much. I love this region. I came skiing many times.
So thank you, Guy. We want to offer you this cake from Grenoble. We may have one question before to go to the break. The break will be a little bit shorter to start the parallel session on time, so it's going to be a 15 minutes break. But before we can have at least one question, and I want to mention that Guy will be with us for the World Conference. So if you want to discuss further the human systems integration topic, feel free to discuss with him. So is there any question in the room? Alain?
Yes, Guy, excellent keynote. Thank you very much. It is already, let's say, advertised on LinkedIn already with a beautiful picture of you. But anyway, I did not see, maybe I was not so attentive, I did not see the term requirements and requirements management. How do you manage the requirements? Because there is also permanent evolution of requirements. With respect to that, I did not see requirements on the slides. Okay, so is it? Did you forget to put it, or no? I'm joking, obviously. Please.
Okay, good remark, thank you. In fact, the requirements are very important, of course, but they are not requirements in the sense, in this approach, in the sense of what we used to do. Requirements in the beginning, and then we keep up with that till the end. The requirements are changing all the time, in fact. And in fact, I think we should have, this is a good point. I think we should put that in the discussion, of course. I mean, this is very important. But we are, you know, the requirements are, a long time ago, they were done, they were written on paper. You know, we used to write, you know, I remember documents, you know, specifications, you know, this is, and then you have to follow the specification and verify that it was done, you know, this verification, very important. Today, with the agile approach, with this approach that we are developing in HSI, the requirements are changing all the time, almost all the time. And then you have to keep, you know, this is a very important thing. The documentation is no longer a static documentation written. It's a vivid documentation. I put that in the slides, vivid documentation. In fact, this is related to your question. This is so the vivid documentation is now even more a simulation, you know, simulating what we mean by, you know, and we are developing, but I cannot say everything there. But we have, behind the representation that I put with the system, we have a representation of these active design documents that we call, or design cards, with 4 spaces. A space for the why, means the design rationale, you know, a space for the how do you implement it, you know, a space for the what. So this is the what is actually the actual rover, for instance. The rover could be the first step in the first step movie, an animation, or a graphic, and then after a while it's going to be the real thing, you know, that is, you know, that, and then the how much is not necessarily the money, but the metrics that you have to evaluate, you know, so we have this, of course, and then the requirements are in these active design documents. So it's more complicated than it looks. Right, right. So sorry, I didn't include that, but I would have been too long.
Okay, we could thank you last time, Guy, and we'll move to the main entrance where you had your registrations for a quick drink before starting the parallel sessions.
Okay, just because we are late, I guess we have to delay a little bit the start of the next session if you want to take a little pause. And just, so I will propose to start at 11 past 5, 5 past 11, sorry for me. And second point, second announcement, for whom has asked Wi-Fi connection, the papers to get your connections are ready at the welcome. So you should have this paper if you ask for it.